to tell you about annuities. And annuities occur all around us. These are sums of money, that the series of payments that occur. In fact, any number of, I mean, you can think about all of the loan related applications, and I bet you can come up with many examples of annuities. Some of the common ones are mortgage payments, house pay, car payments, any kind of payments which require a payment, usually equal amounts of payments every so often, right? So it, like I said, these loans that you have, mortgage related or auto loans or any other kind of loans that have equal monthly payment requirements, where you have to make these equal monthly payments to pay off your loan over an extended period, those are examples of annuities. Okay, so you have as you become more familiar with these concepts, I would challenge you to look around you and find other examples of annuities that you see happening all around you. So in this case, let's look at what happens and how to value these sums of money in the future or at present from the future. So it's the same kind of thing. We're calculating future value of annuities or present value of annuities, because we want to know how much a given series of payments are going to be worth at some point in the future, which is a future value problem. Or we are given a series of payments that occur down the road, and we wish to compute its equivalent present value, a single sum that represents the present value of those series of payments that occur in the future. So here is an example. The timeline, very good way to understand annuities. So 0 being the present, and then 1, 2, 3, 4, 5, those are the periods. And let's say there's 5 payments of $1,000 occurring at each of end of periods 1 through 5. So number of payments in this annuity stream is 5. Now, if we wish to calculate the future value of these series of payments, there are two ways to do it. One is the long way, which is treating each of these sums on the timeline as single sums and then moving them individually to the future, right? So that's, in this example, time 5. So you, for example, take the $1,000 payment that occurs at time 1, move it 4 periods to time 5. Take the $1,000 payment that occurs at time 2, move it 3 periods to time 5. Do the same for the $1,000 that occurs at time 3, move it 2 periods to time 5. Take the $1,000 that occurs at time 4, move it 1 period to time 5. And finally, the $1,000 occurring at time 5 stays the same. It doesn't change in value at time 5 right there. And if you add up all these at time 5, remember I told you in an earlier video that when you move sums of money to the same point in time, it's perfectly fine to add them. You can add them together, sums of money that occur at the same point in time. So you can do that, and you can see at the lower left-hand corner of the presentation, that's exactly what I've done. I've moved all those monies individually to time 5, and then we'll simply add up vertically. And that sum represents the future value of this series of payments at time 5 under a compounded rate of 5%. In this case, it's annual compounding. So that's the hard way or the long way to do the problem. Turns out we have a shorter way and a more elegant way to solve the same problem and get the same answer. And that is through these future value or present value of annuity formulas. So here in this case, let me introduce you to the first annuity formula, which is given here on the slide as future value of annuity, that's the FVA, equals CF. CF is the cash flow, a typical cash flow in this annuity stream, multiplied by or times 1 plus I being the interest rate every period, raised to the power n, then minus 1, and the whole thing divided by I, the interest rate. Now, the first thing to pay attention when you're talking about annuities is that the term n, which before, when single sums were concerned, n was what? If you recall, n denoted the number of periods. Number of periods. In an annuity world, n denotes the number of annuity payments in the annuity stream. The number of annuity payments in the stream. So in this case, N is 5 because there are 5 payments of $1,000 in this annuity stream. So that's the slight switch you have to make when you move from single sums to annuities, is that you have to make the adjustment for N now representing the number of annuity payments in that stream. In this case, again, let me reiterate, N equals 5 simply because there are $5,000 payments involved. If there were 6 or 7, then N would be those numbers, 6 or 7. So you can simply use this formula. The future value of annuity equals the cash flow times this term here, the product term. And therefore, if you substitute in those values, which I've done in the next line, you will see that the future value of this is as calculated and given to you. And this sum is located at the day of that last payment, which is time 5. So the future value of annuity using this formula at time 5 is exactly that number.